here we go. Hi, 4th grade. It's Mrs. Boswell. Today in math for Module 4, we're going to do Module 4, Lesson 14. Ooh, look, I already had a mistake in there. We're doing Lesson 14. And it's going to be defining and constructing triangles. And we've been talking about triangles and different triangles. And we talked about classifying triangles yesterday. So we're going to do more with triangles. Mine is on page 13 and 14. Yours might be a little bit different. Remember, you can pause the video at any time to rewatch or pause it so you can keep writing. I'm going to open up to our notes. Okay. And our I can statement today says, I can define and construct triangles from given criteria and explore symmetry in triangles. So we're going to come over here and we're going to fill in some of this vocabulary, and it's just kind of a review from the last few days. And we're going to talk about an isosceles triangle. So we know that a triangle that has at least 2 sides the same length is an isosceles triangle. Well, let's think about a triangle. How many sides does a triangle have? If I look at that word tri, I know that means 3. So out of the 3 sides on an isosceles triangle, 2 of them have to be the same length. Okay? On a scalene triangle, a triangle that has 3, so this time it's 3 sides that are different lengths. So up here, an isosceles has to have 2 sides the same length, the third does not. This one says it has to, a scalene triangle has 3 sides that are different. And our last one is the equilateral triangle. And if I look at that word equilateral, I'm going to look at this word equal at the beginning, that base word right there. Ooh, so an equilateral is a triangle that has 3 equal side lengths. So all the sides are the same length. Okay, so we're going to take this vocabulary along with other vocabulary we've learned so far, and we're going to construct and define. So here we go. Our first one says to construct an obtuse isosceles triangle. So we're making a triangle that has 3 sides. Okay, let's talk about isosceles. Isosceles means it's going to have 2 sides that are the same length, but then they've added this extra word, this other word, obtuse. So it has to be obtuse, isosceles, and it's a triangle. Okay, so it has to have 3 sides. Okay, and isosceles is 2 that are equal. So I'm at 2, right? And then it has this word obtuse. Well, I remember learning about obtuse earlier, and I have this little hint box down here for you. And it says, remember, an obtuse triangle or angle has an angle greater than 90 degrees or it's greater than a right angle. So remember, here's our template that we used, and remember a right angle makes a perfect square. So we know that it has to be bigger than that perfect square. So if I have my side here, its side would come out. So it has to be bigger than that 90 degrees. Okay, so we're going to say greater than 90 degrees. So kind of my 3 things I have to think. So I'm making a triangle. 2 sides have to be equal, and then have to have the same length, and then it's obtuse, meaning the angle is greater than 90 degrees or greater than a right angle. So I'm going to take my ruler here, okay, and I'm just going to measure it because it says on an isosceles it says the length has to be the same. So that's why we're going to use a ruler today. So if you don't have your ruler, go and grab that. You can pause the video. So I'm going to start here. I'm going to draw a side that has one side that has 2 inches long. So this side is 2 inches, right? Now, it says my angle, right? So I know I'm doing an isosceles. The other side has to be 2 inches, right? But this comes here to the angle, right? So it says it has to be obtuse. It has to be bigger than 90 degrees. Well, this would make a perfect square. So can I do it this way? Nope. I need to bring that ruler out just a little bit because it has to be bigger than or larger than 90 degrees. But I don't also want to go off my paper, so I'm going to make sure those corners connect. And I know that it has to be 2 inches. So this side has to be 2 inches because for it to be isosceles, 2 sides have to have the same length. So this is the same length as this side. Does my third side have to be the same? No, that's only on an equilateral. Okay, so then I'm going to, because I have to make sure it's a triangle, I only have 2 sides right now. I have to draw in that last side. So I'm going to use my straight edge. And I'm going to connect those 2 sides. Did we construct an obtuse isosceles triangle? Well, let's check it out. It has 3 sides, right? 2 sides have to be the same length. This has 2 inches. This has 2 inches. And the angle is obtuse. Well, if I look at these angles, are those obtuse? These ones are actually acute. But it only means I have to have one angle that's obtuse. Well, let's look. Was this one? Let me pull out this. Did it go straight down? Ooh, it's larger than a right angle. So, is this angle obtuse? Yes. So, did we construct one? It says, do we have an obtuse triangle that is also an isosceles triangle? Yes, we do. It says, let's look back at our definitions to make sure. And that's what we kind of did just now. Okay? So, we constructed an obtuse isosceles triangle. It has 2 sides the same length, but it's a triangle with 3 sides. Our next step says we need to create or construct a right scalene triangle. All right, so a triangle has 3 sides. Scalene, ooh, I like this one. The 3 sides can be different. So 3 different, right? But then it says it has to be a right angle. Ah, right angle. So that means, remember, let's go down to here. It says, remember that a right angle is 90 degrees or makes a perfect square. So, I love this. My lengths don't have to be the same. I could use my straight edge ruler if I wanted. Okay, I'm not going to. I'm going to just use this straight edge because I don't even have to measure it. So I'm going to draw one side. And then I got to keep them connected because I want a right corner, right? Is this side the same length as this side? No. But do I need to connect them? Yes. So now I can pull in my ruler, my straight edge ruler to connect them. Okay. So let's check it out. Let's measure it. I know that this side is about 2.5 inches. Okay. This side is about 1 inch. And the other side measures about 3 inches. I'll kind of just round it up a little bit. So let's see. Did I construct a triangle? Yes. Okay, let's go back to Scalene. It says a triangle that has three sides that are different. Ooh, this side is 2.5, 1 and 3, so that's all different. So we're kind of looking back and making sure, have we made this triangle? But then it says I have to have a right angle. Did I create that right angle? Let's put it in. I did, but do I need to have that symbol? Yes, so here's my right angle. So I have that drawn in. Okay, so now have we created a triangle that is also a scalene triangle? Yes, we have. All right, let's move on to our page 2 of our notes. I'll bring this down a little bit so you can see. So remember, we're going to be defining and constructing some triangles, okay? But we have, this time, instead of telling us what to construct, it's asking, can we construct these? So all 3 of these are questions, okay? So this one says, can a triangle, so a triangle, 3 sides, be both scalene and equilateral? Well, I know scalene is 3 different sides, and equilateral is 3 equal sides. Oh man, I can already see some conflicting things here. So I kind of use that definition. That definition is pretty important on those words. Okay, so I can make a triangle But it says, can it be scalene and equilateral? Well, equilateral means it has 3 equal sides, so all the sides are the same length. But a scalene triangle has 3 different sides. So do I even need to construct it? I don't, because what's my answer already? Is that answer yes or no? If you said no, you're correct. Why is it no? Well, if I go back up to that definition, a scalene has a triangle that has 3 different sides, but an equilateral has 3 equal sides. So the reason is a scalene triangle has 3 different side lengths and an equilateral has 3 equal side lengths. Remember, you can pause the video at any time. So the reason I know, and that you will have to explain your thoughts on the lesson today and kind of really work through them. I already know I can't even draw it because 3 different sides is not the same as 3 equal sides. That's why I don't even need to draw my picture here. I just need to explain it in my words. So those definitions are going to become really important. Okay. Now this says, can an equilateral triangle also be obtuse? So let's find out. Well, equilateral, so a triangle, remember, 3 sides. And the equilateral means it has to be 3 equal lengths. Okay? And obtuse is larger than a right angle. So let's find out if we can do it. Okay? So I'm just going to start with my straight edge. I'm going to measure this one. We'll make them each 2, and we'll find out if we can make them. So there's 2. But I have to make one angle larger than 90 degrees. So that would line up. So I got to make it just a tad bit. And I want that to be 2. Well, I'm going to go into my other lane. That's okay, just a little bit. So this is 2 inches. This is 2 inches. Okay, but if I connect them, this one is 3 inches. So, did I make it obtuse? Let's double check, right? Okay, it didn't line up correctly, so that is a little larger than 90 degrees. Okay, I have 2, it is a triangle, right? It is obtuse, but did it have 3 equal lengths? Well, let's see. 2, 2, and 3. Oops, so sorry. I apologize. Sorry. Look, it ended up 2, 2, and 3. Is that equal? Are all sides the same length? 2, 2, and 2? Nope. So we're going to say no and explain your thoughts. Because one side would be longer. Alright, so let's do this next one. This says, I'm imagining an equilateral right triangle. Can it exist? Well, let's find out. Ooh, I like right triangles. Let's try this out. So I'm going to make this one. We're just going to do this 1 inch. So here's 1 inch. Now I have to make sure that when I do the other side that it is 90 degrees. I might even line it up with my paper. Okay, ooh, that's perfect. Make sure I line it up. Okay, so I'm going to make that 1 inch. Okay, so then I got my 90-degree corner. Okay, each of these sides, oops, sorry. So I got my 90-degree corner. This is 1 inch. This is 1 inch. So what I'm hoping is when I draw this side, it is also 1 inch. Let's see. Ooh. Did it end up 1 inch? Well, let's see. Actually, here's 1 inch and 1 inch. It's a little longer than the 1 inch. So let's make sure I lined it up. So there's 1 inch, 1 inch. But if I were to draw this, I needed this side to be 1 inch. Is it 1 inch? If you noticed, it's a little longer. It's about 1.5 inches. So let's answer that question. Can an equilateral right triangle, can it exist? What do we have to say? We would have to say no. Okay, and why? Because one side is longer than the other two sides. Today, 4th grade, you're going to do more questions and you will have to kind of figure it out, but it's really important that you understand the vocabulary of what is an isosceles triangle, what's a scalene triangle, what's an equilateral triangle, okay? And make sure that you're constructing them and you're defining them, but you also need to understand what's obtuse and a right angle, okay, and an acute. Good luck today.